Hello students. In this video we will study about the meter bridge. So first of all we have to know what is the meter bridge. Actually meter bridge is the simplest practical application of Wheatstone bridge. Okay, because this is the application of Wheatstone bridge, that's why it works on the principle of Wheatstone bridge. Okay, and the principle of meter bridge will be same as the principle of Wheatstone bridge. So first of all you have to know what is the principle of Wheatstone bridge. In the previous lecture we have already studied about the principle of Wheatstone bridge. Okay, so we are looking here, we are remembering here about the Wheatstone bridge. You know, Wheatstone bridges are having 4 resistors. So in the case of meter bridge should be having also 4 resistors. No? So we will discuss about the construction of meter bridge just. So first of all, what is the principle of Wheatstone bridge? In the Wheatstone bridge, 4 resistors are connected in the arms of the quadrilateral. Okay, and current is made to flow by this electric source. Okay, this one and this one, these two resistors are adjusted so that here in the galvanometer no deflection is there. In this condition, this Wheatstone bridge is said to be in the balanced condition or in the equilibrium condition. Okay, so in the equilibrium condition, this Wheatstone bridge is said to be the balanced Wheatstone bridge. In the balanced condition, the resistance of two resistors adjacent at that point, let the resistance of this resistor is P and resistance of this is Q. So the ratio of the resistance of adjacent resistors is equal to the other resistance of resistors adjacent. So this will be R upon S. So here this is the principle of Wheatstone bridge. So the principle of meter bridge should be same. So first of all we have to understand the construction of a meter bridge. In the construction of meter bridge, here rectangular shape wooden block is taken, and over the wooden block here 1 meter constantan or manganese wire is fixed in the one side of the wooden block like that. This is 1 meter wire A and C. Okay, and the first end of this 1 meter alloy wire is soldered with the L-shaped strip of copper, and other end of this wire is also soldered with the L-shaped copper strip. These are the two L-shaped copper strips. Between two shapes here another strip is taken, that is okay. Now, and this is the first gap and this is called second gap. Here in the first gap resistance box is connected. What is resistance box? Actually resistance box is the box of resistors. In the resistance box, over the surface of the resistance box, here many resistors are fitted like that. We can take out any resistance from this resistance box, and this will be the value of R. So if here near the keys of the resistance box written the resistance of the keys like that, 1 ohm, 2 ohm, 3 ohm, 4 ohm, 5 ohm, or 2 ohm, 5 ohm, 10 ohm, 100 ohm, like that. Okay, the key is taken out from the resistance box, then the value of the resistance box will be let this is and this 3 ohm 3 ohm keys is taken out, so the value of R will be 3 ohm. Okay, so we will discuss about the resistance box in other lecture. Here you have to know only about the resistance box, and in the other gap here unknown resistor is connected, that which we have to find the resistance of this unknown resistor. Okay, now, and let this is the point A and this is C. Between point A and C here cell is connected, and with point D, from point D here a galvanometer is connected, and with the galvanometer here jockey is connected. Okay, and to find the balancing point here a scale is made here on over the wooden plank or wooden board. Okay, this is the construction of the meter bridge. Now what is the working of meter bridge? We will understand about the working. Okay, when this key is injected, then current will be flowing through this conductor, and current will be flowing through this alloy wire from A to C. Actually alloy, this is the 1 meter wire, and this 1 meter wire is taken in the meter bridge. That's why this bridge is also called meter bridge. Okay, why this wire is taken of alloy? Because here should be the potential drop, here should be the potential drop. Okay, and when current is flowing through this wire here, you know that when current is flowing through any conductor for long time, here heat is produced in the conductor or wire. Due to this, temperature is increased, then the resistance will change or resistance will increase. When the resistance will increase of this wire, so the resistance in each unit length, like that, this is the first centimeter, second centimeter, and the length of this wire is 100 centimeter. So each 1 centimeter, in the each 1 centimeter of this wire, here the resistance will not be equal, or the resistance in this wire will not be uniform. Okay, so that's why this alloy is taken, because the temperature coefficient of alloy is very less. That's why here if temperature is increased for some degree of Celsius, so the resistance of this wire does not change with the increase in the temperature of this wire. If this wire would the conductor wire, so the resistance in per unit length would be changed. That's why this wire is taken of alloy. Okay, and these strips are taken of conductor, and thicker strips are there. Why this? Because here when current is made to flow, so here will be current will be flowing, and the potential drop should not be there in the strips. If current will be changed, then the actual resistance of this unknown wire we will not be able to calculate. That's why these should be of metals, and in these strips the potential drop should not be there. Okay, and these strips are taken thicker. Why? Because some resistance are there of these strips. Okay, due to the resistance of ending of the strips, ending, this end point, this is end point, this is end point. So in the ending of the strips, here some resistance will be there. This resistance is called end resistance. So due to the end resistance, here the value of this unknown wire should not be calculated. Cannot be calculated. That's why these wire and these strips are taken thicker. Okay. Now from this point D, here galvanometer is connected, and with the galvanometer here the jockey is connected. When current is made to flow through this wire, then some current of the total current here, current will be flowing through the strips. Okay. Now, and current will be flowing through the resistance box, and current will be also flowing through the unknown resistance, and current will be also flowing through the galvanometer, and current will be also flowing through the wire AC. Okay, so current divided into two ways here at point A. Okay, now current here from towards this side, and through the wire AC A to B. Okay, when this jockey is brought near the point A, then the deflection will be left side or one side, and if this jockey is brought near the point C, then the deflection will be opposite side. Deflection of this pointer of the galvanometer will be opposite side. Okay, now then this circuit for the practical purpose is correct, otherwise we have to correct the circuit again. Okay, and if the deflections are opposite in the two cases, then now here this jockey is brought near the point E, then deflection will be more. If this jockey is moved along this wire towards point C, then the deflection decreases. At any point on this wire, here deflection will be 0 on the galvanometer. This 0 deflection means here no deflection is there in the galvanometer. In this case, this meter bridge is said to be balanced. Okay, because this is the principle of this meter bridge is based on the principle of Wheatstone bridge. So that this will work same as the Wheatstone bridge. So at the 0 deflection, here this point where zero deflection occurred, so this point is said to be the null point. Let this is point B, or somewhere this is taken as J. So B, we are taking here B. So this point is said to be a null point. Okay, now we have to find the length of this null point, or we have to find the length or the distance of this null point from A. Let this is L, and now because this total distance length of this wire is 100 centimeter, that's why this length will be 100 minus L centimeter. Okay, now in the practical, first of all, this from the resistance box, here any key is taken out, and Then this jockey is brought near the A, then deflection will be one side. When this is brought near the C, then this deflection will be opposite side. So here from the resistance box, let here 3 ohm key is taken. So the resistance of the resistance box will be 3 ohm. And so this because the value of the resistance box, we are knowing the value, so this resistance box is called the known resistance. Okay, and this is unknown resistance, and we have to find the resistance of this L length of the wire. So let the resistance per unit length means resistance should be of 1 centimeter or 1 millimeter. So generally it is taken the resistance of 1 centimeter. This is called the per unit resistance per unit length of the wire. Okay, so let this the resistance is small r, per unit, the resistance of per unit length of this wire is r. Then the resistance of length L will be per unit length resistance into total length. This is the resistance of L length wire. Let the resistance of AB is P, and so that this will be P, and let the length of BC is 100 minus L. Then the resistance, let this is Q, so Q will be resistance per unit length of the wire into total length of that part. These are the resistances of AB and BC. Now by the principle of Wheatstone bridge, the principle will be for meter bridge. So by the principle P upon Q equal R upon S. Why? Here 4 resistors are there, first, second, third and fourth, and between them this is the galvanometer. This is same as that of Wheatstone bridge. That's why we will apply the principle of Wheatstone bridge, or this principle will be the principle of meter bridge. So on putting the value here, P is equal R into L and Q is equal R into 100 minus L. It will be equal R upon S. This is known resistance and this is unknown resistance. So we have to find the value of unknown resistance. So what will be the value? Here R cancelled by R. Then here will be L upon 100 minus L equal R upon S. Or the value of unknown resistance S will be on transposing. So here will be S. So in the denominator of the right hand side will be L, and on the numerator of the right hand side will be 100 minus L. So here will be R into 100 minus L upon L. So this is the formula, or this is the principle for the meter bridge, and this is the formula for finding the unknown resistance by the meter bridge. Thus, knowing the value of R and L, the unknown resistance can be determined by this formula. This is equation first.